So let's do the integral of secant cubed of x. There's actually a reduction formula for integrals in the form secant to the n of x, but I'm not going to use it, and I'm just going to show you how you can do this specific integral using integration by parts. So here's how we do it. We start off by doing integration by parts and let u equal secant of x and dv equal secant squared of x dx. This works because if we multiply secant of x with secant squared of x, we end up with secant cubed of x, which is the integrand we're working with. If we use these values, then du equals tan of x secant of x dx, which is the derivative of secant of x, and v equals tangent of x, since the integral of secant squared of x is tangent of x. This comes from the standard derivative of tangent of x, which is secant squared of x. So this means the integral of secant cubed of x is equal to uv, which is tangent of x times secant of x minus the integral of v du, which is minus the integral of tangent squared of x times secant of x dx. We can use the trigonometric identity tangent squared of x plus 1 equals secant squared of x to infer the identity tangent squared of x equals secant squared of x minus 1 if we subtract 1 from both sides of the equality. We can use this to rewrite the tangent squared of x in the integrand as secant squared of x minus 1, so the integral becomes the integral of secant squared of x minus 1 times secant of x dx. If we distribute the terms in the integrand, then this becomes the integral of secant cubed of x minus secant of x dx. And then if we apply linearity, the expression becomes tangent x secant x minus parentheses the integral of secant cubed of x dx minus the integral of secant of x dx. If we distribute the negative sign into the parentheses, this becomes tangent x secant x plus the integral of secant of x dx minus the integral of secant cubed of x dx. And what I've done is I've put the integral of secant of x dx term at the front, and you'll see why in a second. The integral of secant of x term should be positive since the negative and negative term cancel out, and the integral of secant cubed of x term should be negative since the negative outside of the parentheses makes this term negative. The integral of secant of x is equal to ln of the absolute value of tangent x plus secant of x, which I already did a video about, so I'm just going to use it here. If we use this result, then this expression becomes tangent x secant of x plus ln of the absolute value of tangent x plus secant of x minus the integral of secant cubed of x dx. So we should recognize that we started off with the integral of secant cubed of x dx, and after applying the steps we did, we ended up with the expression tangent of x secant of x plus ln of the absolute value of tangent x plus secant x minus the integral of secant cubed of x dx. This means the two expressions are equivalent, so we can form the equation the integral of secant cubed of x dx equals tangent x secant of x plus ln of the absolute value of tangent x plus secant of x minus the integral of secant cubed of x dx. Since the expression for secant cubed of x contains itself, we should solve the equation for the integral to find an expression for the integral that isn't self-referential. To do this, we should add both sides of the equation by the integral of secant cubed of x dx, which results in the equation 2 times the integral of secant cubed of x dx equals tangent x secant of x plus ln of the absolute value of tangent x plus secant of x. And then we just have to divide both sides of the equation by 2, and we get the integral of secant cubed of x dx equals 1/2 tangent x secant of x plus 1/2 times ln of the absolute value of tangent x plus secant of x. plus the constant of integration c. So this means the integral of secant cubed of x dx is just 1/2 tangent x secant x plus 1/2 times ln of the absolute value of tangent x plus secant x plus c.